We're once again asked to find the 6 trig ratios of an angle, which is what we were asked to do in the last video. This problem looks a little bit different, but it turns out that it's really the exact same thing with a couple little twists in it. The first thing that I'm going to recognize is that they give me the sine of theta. It's 3/4. Well, that doesn't really tell me much the way it is, so well, I guess it does, but for me, I'm a very visual person, and so I'm going to want a picture to go along with this. So let's go ahead and draw a right triangle, and then I can put theta wherever I want to, as long as it's not the right angle. So either the top or the bottom angle could be theta. I'm going to call that theta down there, although you could certainly call the top angle theta. Well, keep in mind what the sine of an angle stands for. It tells you that it's the opposite over the hypotenuse, if you think back to Sohcahtoa. So really, they've given me two sides of this triangle. The opposite side from where my angle was placed means that this side is 3, and it means the hypotenuse, the side across from the right angle, is 4. So here's how that problem is very similar to the last problem. There's my picture. Just like last time, the first thing I want to know is what all 3 sides are. So since I'm missing a side, let's go ahead and do Pythagorean Theorem. And keep in mind this time, since we're missing a leg, oops, I already did it wrong. Since I'm missing a leg, it's 3 squared plus that missing leg that we don't know, so we'll call x, equals the hypotenuse squared. So it's not 3 squared plus 4 squared, because 4 is the hypotenuse. So we'll do a little bit of math again to figure out what that missing side is. And you probably noticed in my directions that this time they want their answer in simplified radical form. All that means is we don't have decimals, so we keep things as square roots. So subtracting 9 from both sides gets me 7. And when I take the square root of 7, I'd get an irrational decimal. So I want to leave this exact as the square root of 7, which I'd simplify if I could by doing the factor tree, by breaking that down. But 7 doesn't break down. If you need help with simplifying, go back and watch one of my old videos. Can help you with simplifying. Alright, so I've got all 3 sides figured out. Let's go ahead and label what they are too. That will be helpful. So this side is the opposite of the angle that I identified. The square root of 7 would then be the adjacent side, and 4, as we've already mentioned, is the hypotenuse. So setting up my 3 ratios using Sohcahtoa, let's write that down. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. They already gave me the sine in the problem. That was 3/4. So the sine of theta is 3/4. The cosine of theta is the adjacent side, which is square root of 7, over the hypotenuse. It's okay to have a square root in the top of a fraction. That's not a problem at all. It's not okay to have a square root in the bottom of the fraction. But what are the odds that that happens, right? All right, the tangent of theta then is the opposite over the adjacent. So 3 over the square root of 7. Well, oh shoot, we have a square root in the bottom. We're not allowed to have that, so let's go ahead and real quickly refresh on how to get rid of a square root in the bottom of a fraction. If you need more help, I got a video about this before, or earlier. If you ever end up with a square root in the bottom, the trick is to multiply the top and bottom of that fraction by whatever in the square root. Because really what's in purple is just equal to 1, and multiplying something by 1 doesn't change it. 3 times the square root of 7 then is just 3 square root of 7, and the square root of 7 times square root of 7 is a regular 7. So there's my simplified ratio without the square root in the bottom. It's still in there, but it's no longer in the bottom. Okay? In our last video, we were also introduced to this idea of the 3 reciprocal trig functions. So the reciprocal of sine is called cosecant. So to find the cosecant of theta, just do the reciprocal, flip the sign fraction around, so 4/3. Secant is the reciprocal of cosine, so flipping over my cosine ratio gets me 4 over the square root of 7. Well, once again, we have that square root in the bottom, so I need to simplify that. It's an easy thing to do, though. Multiply top and bottom by that square root, so I end up with 4 times the square root of 7 over regular 7. And then finally, to find the cotangent, which is the reciprocal of tangent, flip your tangent ratio around. Well, I could flip my final answer. However, if I flipped that, I'd end up with a square root in the bottom, which I don't want to do. I could simplify it. However, there's an easier way to do it. Remember, this was the same ratio. We're saying that what's in green and what's in purple are the same exact thing. So let's just flip that one. Nothing says we have to flip the simplified version. The reason I want to flip that is when I flip it, look, my square root ends up in the numerator. So the cotangent of theta will be the square root of 7 over 3.